In this video, we're going to learn how to solve by taking log of both sides of an equation. So here I have an example, 4 equals 3 to the 2x. So in this example, we have used using the same base and raising it to an exponent to get the bases equal. So for example, if I had 4 equals 8 to the 2x, sorry, I can rewrite both of these with a base of 2. So 2 squared is 4, and 2 to the third is 8. So I can rewrite these as a base of 2. But in this example, I can't rewrite 3 as a common base as the 4. So that's why we would have to use logarithms to solve. So when I go to use logarithms to solve, you want to have just a base raised to that unknown exponent on one side. So if there's any multiplication or something added or subtracted here, we'd have to get rid of that first. But here I just have 3 raised to the 2x. So what I'm going to do to get rid of this 3 so I can solve for x easily is take log with that same base 3. So I'm going to take log base 3 of 4 equals log base 3 of 3 to the 2x. Okay, so this step I often skip in showing, but I just want to show it here. This exponent, we can use our exponent rule by writing it in front, dropping it back. So I have log base 3 of 4 equals 2x log base 3 of 3. And then the reason why we use log base 3 of 3 is because if I were to put this in the calculator, so using our change of base rule, that would just be log of 3, so log of the larger number divided by log of 3 divided by that smaller one. So log 3 divided by log 3, that's equal to 1, and that cancels out. So I'm just left with 1 times 2x, which is just 2x. So what I want to do next is calculate what's log base 3 of 4. So again, I'm going to use my change of base rule. I'm going to do log 4 divided by log 3. Okay, so when I type that in here, I have log 4, close my parentheses, divided by log 3. Okay, so I get this decimal. I'm only going to write part of the decimal on here, but I'm going to leave it in my calculator. So this will be, continue over here, 1.2618, I'll just write that for now, equals 2x because our log base 3 canceled here. And then what's left is dividing by 2 to get x alone. So I left that number in my calculator, and now I'm just going to hit the division key, divided by 2. And that's going to be x equals 0.6309, or we could do 0.631, but it doesn't come out pretty. That would be it for that one. Okay, so with these word problems, how to find that amount of time, we're going to be using this log with the base rule. Okay, so here you deposit $1,000 into an account with 5.2% interest, compounded monthly. So that's our keyword here. That's how I know I'm going to use this formula. If it's continuously, like down here, I'm using the formula with E. And then how long until you have $3,500? Okay, so my principal is this 1,000. That's how much I deposited. And then I have 1 plus the rate, 5.2%. So remember to convert your percent into decimals. 5.2 divided by 100 is how you convert that into a decimal, or just know to move that decimal place over 2 spaces. So this is 0.052. So 0.052 divided by, and it's compounded monthly, so there's 12 months in a year, and it's to the NT, so 12T. And we have an amount, we have how long until it's equal to 3,500. Okay, so what I'm going to do first is this number is being raised to the 12T, so I'm going to divide out 1,000 first. Okay, that's going to end up with 3.5 equals, and let's calculate what this will be about with a decimal. So we'll have 0.052 divided by 12, and then plus 1. And I'm going to write this out as 1.00433. That's as far as I think I really need to go. We put it out to more decimal places so that we have a more accurate answer. So this is raised to the 12t. Okay, so at this point I'm at where we started with here, except we're working with decimals. So my next step is I'm going to take log with the same base that's raised to that unknown exponent. So I'm going to have log base of this number on both sides. Okay, so on the left side I'll have log base 1.00433 of 3.5 equals log base 1.00433 of that same number, 1.00433 to the 12t. Okay, so again, if you have log with this base that's the same as the number that it's of, that's going to cancel. That's why we take the log of both sides. Okay, so I'm going to calculate this by doing my change of base rule. So that would be log 3.5, the larger number here, divided by log 1.00433. So when I calculate that, I have log 3.5 divided by log 1.00433 equals. Okay, so I'll write this number down, but I'm going to keep it in my calculator. So this will be 289.94, and I'll round up just for on paper, but I'm going to leave the actual number in my calculator, equals, and since this canceled out, we're just left with this 12t. So just remember how we're just left with the 12t, that exponent rule, how it goes in front, and 1 times this number, we're just left with that unknown exponent. So here we have 12t. So the last step to solve for t is to divide by 12. So now I'm going to hit divide by 12, and I have t equals 24.16. So it's like about 24 years until I reach $3,500 by depositing 1,000. Okay, so that's the example when it's compounded monthly. But now let's look at an example when it's compounded continuously. So here's our keyword down here. So you're depositing the same amount. So we're using the same information as up here, except we have it's compounded continuously instead of monthly. Okay, so I'm going to set this up the same. I have what we deposited, so that's going to be the same, 1,000. And we have E, so that's just our number E. And then R is our rate. So again, I'm going to use 0.052. We're using all the same information, except we're continuous. And then we're going to set that equal to 3,500. Okay, so in this problem, I'm trying to get this number E raised to the exponent alone. So the first thing I'm going to do is divide by 1,000. So this will end up being 3.5 again, equals e to the 0.052t. Okay, so when we take the base of, take log of both sides, I want my base to be the same as this number raised to the unknown exponent. So I want log with a base of e. And we have something we can use for that, and that's just our natural log. Natural log is log base e. So I don't have to write log base e because I'm just going to use ln. So on this side, I'll have ln 3.5. And on the other side, I'll have ln e to the 0.052t. Okay, ln 3.5, you just type in your ln button and then 3.5 equals, and I have 1.2528. I'll round here, but keeping that number in my calculator equals ln e is what cancels. Log base e of e, that's just going to equal 1. So that's what ln e, that's the same thing, that's equal to 1. So that's why it cancels here. And I'm just left with 0.052 t. And then the last step here is to divide by that 0.052. Okay, so on here I'm going to divide by 0.052, and we get t equals 24.09. So look how close between monthly and continuously. Just by 0.1 is really the difference. So again, we have about 24 years for this amount also.